our media team that I'm good to go. Yes? Great. Thank you. Okay. Hello. Welcome to the CERI seminar series, to our participants online and here in the room at Center for Epidemic Response and Innovation, CERI, here at Stellenbosch University. It is a pleasure to welcome you to this session today. For those of you who haven't been here before, these seminar series, we like to invite world-renowned researchers to this community to share their research and their journey with us. By us, I mean this collection of people here and online with diverse backgrounds and different levels of expertise, with the aim of getting us talking, getting us learning new things, getting us creative, getting us inspired. And I really hope that, actually, I don't even hope, I know that you will be inspired by the topic and by the presenter today. And I'm going to tell you why in a few moments. She told me not to embarrass her, but I will, just for a little bit. I've got host, that's the responsibility of the host of a meeting, I suppose. I was telling you about what I'd like to see within this meeting, this sort of connection. And the reason we want these connections within this meeting is so that ultimately, by inspiring, getting people to work together, we will be able to work together to answer key questions, address those problems that will ultimately lead us to solving issues like, how do we prevent and control infectious diseases? How do we promote and improve public health? And that's going to be a large topic of today's particular conversation. So thank you very much for joining us today. I'm Lenine Liebenberg. I'm a chief researcher here at CERI, and it is my absolute pleasure to introduce today our world-renowned researcher, Professor Jo-Ann Passmore. Jo-Ann is a principal medical scientist at the NHLS. She is a professor of medical virology at UCT in Cape Town, where she also leads the mucosal infections group that focuses on understanding the immune and microbial environment that contributes to reproductive health. She co-developed GIFT, which you will hear lots more about today. And during her career, she has received many prestigious awards, including the Callistus Juma Scientific Leadership Fellowship from the Bill and Melinda Gates Foundation. There's so much to tell about this wonderful human being. And I'm going to get to the more personal bits in a little bit. She's published over 100 papers, and all of this contributes to her building a very important body of work that promotes our understanding of reproductive health in women. Now, I've known Jo-Ann for actually more than 20 years. We were introduced in 2003, 2004, I think, where she agreed to supervise my honors project. So this is a very personal experience here for me. It's an honor to present my previous supervisor, now mentor and colleague to this meeting. And for anybody who does know me, you will know how much I scream to the rooftops about how important an effective mentorship relationship is. And I've been fortunate to have that at UCT through Jo-Ann and other mentors, at Caprisa in Durban, at Stellenbosch University, and abroad. Knowing Jo-Ann, it's not only her knowing me and helping me grow as an independent scientist, but I've also had the opportunity to watch her grow. Being one of her first students many years ago, but you've expanded from 2 to what? over 30 plus, not only in South Africa, but around the world. I've seen her prepare for grant applications and interviews. I've seen her celebrate the wins. I've seen her and commiserated with the rejections and rework it into something else that will then get funded, which is absolutely a wonderful lesson to learn for all researchers out there. I've seen her graduate PhDs. I was one of them with her waving at me on the days. It was wonderful to see. But I think what I've really, really taken away from my experience watching Jo-Ann grow is that it's not enough to put on a lab coat and do some cool science in the lab, right? What's truly pleasurable about it is helping people grow during that experience and also translate this cool research into something that people can use, that people can benefit from. And that's what I'd like for you to take away from this meeting today. She will explain to you her journey, the research that got her to where she is today, and how this technology is going to help, to me, save the world, Jo-Ann. So thank you very much for being there. Did I give you enough time to get a breather? Okay, wonderful. Please join me in welcoming Professor Jo-Ann Passmore.
So I'm suitably embarrassed, and I think I sound quite smart after Lenine's introduction, but clearly having had students like Lenine that I've benefited from, we all stand on the, the shoulders of the achievements of our mentees. So thanks for the lovely introduction, Lenine. Okay, so just in terms of introducing our research group to you, we broadly got two big projects that we focus on. All of the research we do focuses on preventing HIV infection in women. As a mucosal immunologist, I've done this, we focused on two kind of key developments. And the one is developing novel diagnostics for picking up sexually transmitted infections, focusing on inflammatory biomarkers, and that's the Genital Inflammation Test I'll be talking about today. And then the other big project that we work on with Lenine and with many others in South Africa and internationally is developing a better treatment for bacterial vaginosis, which from the research we and others have done is one of the biggest drivers of genital inflammation. And Lenine sort of said about the size of the group, but I'm standing here talking to you about the amazing research our group does, and these are the actual people on the bench doing all the amazing work. And since this is a little bit of a reflection of the journey, mentorship and being involved in other people's professional development is like one of the biggest gifts we have as supervisors. So each of the people in this picture, their success is my success, which is a way of like amplifying things. So I just wanted to give them an acknowledgement up front. And then this is a very old photograph you'll see. I look identical today that I did all those years ago, but that was like about 2013. So it's like more than 10 years ago now. And that's me on the right and Lindy Masson on the left, who was, I think, about one of sixth PhD student that came through the work, I think a contemporary of Lenine's, a little bit, in the lab at the same time as you. And we've all been very fortunate to work with Caprisa in Durban, and a lot of the PhD work that came out of her research went towards developing the thinking and the kind of the rationale behind the gift test. This is the paper now published in 2015, which was one of the most important papers from Lindy's PhD. And I'm not going to be pointing, but I'm just going to be saying through this figure, which many of you may have seen, because I have presented it quite widely, because it really does tell, a picture tells 1,000 words. This was a case control cohort study from CERI, and we were following women prior to HIV infection. In that study, HIV infection was the endpoint of the study, and out of the nearly 1,000 women that participated, 58 subsequently became HIV infected, and then we matched those to 58 controls who were in the study for the duration of the study but remained HIV negative, and so the yellow squares above here are all the remaining negative women, and the blue squares are all those women who subsequently went on to acquire HIV infection. And we measured 12 cytokines and chemokines that previously our group had shown were really influential in determining inflammation associated with HIV risk. And you'll note that the woman who subsequently acquired HIV had a pre-existing inflammation prior to the HIV infection that increased their HIV risk adjusted odds ratio of 3.2. That was significant. And in this analysis from Lindy, genital inflammation being present was defined since we measured like 9 chemokines and inflammatory cytokines, more than half of those being above the in the 75th percentile was considered to have inflammation, and then everyone else had no inflammation. So that's translated in sort of, these are building blocks and how our group's brains work, but trying to understand the impact of that genital inflammation on prevention strategies. So CERI at that time was testing a topical antiretroviral based microbicide to prevent HIV infection. And this is work, you'll see Lenine was co-first author on this Nature paper. We looked at the juxtaposition of inflammation in women who became infected and were using tenofovir versus those who stayed negative. And what this analysis from Lenine and Lyle showed was that genital inflammation undermined the protective effects of tenofovir. So in that very potent antimicrobial, antiviral microbicide trial, having genital inflammation still increased HIV risk in women using the active compound. And obviously we were very interested because inflammation in its own right is just like smoke signal telling you there's something going on, there's a damaged mucosal barrier, but something's causing the inflammation. And at that stage, it's sort of waiting for bricks to fall into place. But T. vaginalis was the strongest predictor of inflammation in that cohort, but it wasn't significantly associated with inflammation. Chlamydia and gonorrhea, HSV2, none of those usual suspects really explained the inflammation we were seeing. And in fact, only 20% of the HIV infections we observed in that study could be attributed to an STI. And at that stage, we didn't have bacterial vaginosis information. Nugent score and microbiome wasn't performed during that study. And I think that was the early part of what Lenine moved to Durban to focus on, was the microbiome contribution to genital inflammation. And this is work that has never been published. Another lesson in it's really good to publish your results so that you can cite them other than just a conference presentation. But this was presented in Durban in 2016, and this is a collaboration with Columbia University, and looking at the case control design. We presented in the 2015 paper, where on the bottom little blocks you can see HIV status. So the red indicates women who went on to become HIV infected. Gray is those women, the 58 that remained HIV negative, and then the inflammation group, they fell into orange being having elevated inflammation, and in this analysis they stratified the no inflammation into two groups in two different color greens. And the take-home message, and I apologize for the quality of this figure, but microbiome researchers and me as an enthusiast of microbiome research love seeing complexity in data. A female reproductive tract that has Lactobacillus crispatus is a happy, quiet, non-inflamed environment, low pH, very, very homogeneously colonized by crispatus, which effectively keep out the other pathobionts and dysbiosis. In many women, there's this sort of transitory species of lactobacillus called Lactobacillus iners, which does not produce lactic acid, it doesn't lower pHs effectively, and it also doesn't outcompete or keep the pathobionts at bay. And what I hope you can see from this is that if women had crispatus, they were more likely to be in the remain HIV uninfected. They were more likely to be green in terms of their inflammation status and not have a lot of inflammation. But in fact, the women who had the most inflammation and most of the HIV infections were sitting with a very dysbiotic vaginal microbiome, with Prevotella bivia in particular in this study appearing to be causing inflammation. And then we recapitulated these findings locally in Cape Town and Johannesburg, and women participating in those studies. And this is a colleague of mine, Heather Jaspin, who's at Seattle Children's Research Institute, and a very talented postdoc at the time, Katie Leonard, who is a bioinformatician, and essentially having Prevotella bivia and inflammation was not unique to women in KwaZulu-Natal. It was a phenotype we could identify in women living in Cape Town and in Johannesburg. So sort of taking a step back to now, like kind of the thinking behind GIFT, using all of this information we'd gained earlier, was that having an STI is the leading cause of HIV risk and adverse birth outcomes. But more than 80% of women in most low middle income countries don't know they've got an infection. They don't have overt symptoms that a clinician would identify, and that therefore they don't know to reach out to healthcare providers. This is my little kind of aside on what is asymptomatic, because I've had many discussions with clinicians about if a woman doesn't have symptoms, should you worry about her? And the point is we've come a long way in the last 50 years in terms of identifying inflammation that isn't clinically evident. So you don't have to have like active vaginal discharge that's pussy colored and smelly to know a woman's inflamed anymore. They're more sensitive biomarkers that are present that can alert women to something funky going on, even if they're not clinically experiencing massive overt symptoms. And you know, there are various definitions of what asymptomatic means. And for us, I choose the last, is that the symptoms are subclinical and not clinically evident. Women don't look up their vaginas every morning to see symptoms, and therefore they're not, you know, in active case finding mode. So, and this is actually is a fact. The most common symptom of having an STI, sexually transmitted infection, or bacterial vaginosis is no symptom at all. So going back to in terms of what our medical students are taught about what inflammation is, it's a classic signs and symptoms: swelling, redness, warmness, pain, loss of function. and that doesn't perfectly translate to gynecology, basically. And the fact is that the discovery of cellular and molecular inflammatory mediators and the development of sensitive biomarkers have rapidly advanced our understanding of what inflammation is. So even if you can't see it overtly, it still exists and still has consequences like increased HIV risk. And the biomarkers, some of us are more some of these are more familiar to us, like C-reactive protein. There are quite a few point-of-care tests for C-reactive protein for systemic inflammation. So if you're worrying your patient's got systemic inflammation, you might ask for CRP test, or you might do an interleukin test from the labs. But there are many others, and they generally indicators that an immune system is activated in some way. There's cellular recruitment to the site of challenge. And then I was always very scared about chemokines and cytokines because they've got very weird and wonderful names, and they like pleiotropic, and they cross, they have cross functions, and what, you have to learn all 1,000 of them. But they're really interesting from a biochemistry point of view. They're very small proteins, about less than 100 kilodaltons, and they're produced by certain cells as calling cards to call and recruit other cells. They have a very powerful orchestrating role in the immune system, and they sometimes stimulate immune cells. They can also slow down the immune system by inducing regulation, but most importantly, they cause chemotaxis. So they allow cells moving from our lymph nodes and our spleen, immune cells, to move out of the blood and spleen to the site where we need those immune cells to be. And it kind of be like a snap call, and immune cells will start infiltrating into a tissue. So they call other immune cells into sites of pathology. And what we did with this information, so actually a really important cold call email from a scientist at Imperial College, no, not Imperial, from Ireland, Trinity College, and he had reviewed one of the grants I'd submitted early days, and he was part of a Horizon 2020 initiative. He was working in HPV cervical cancer diagnostics. He was in Cape Town at some HPV conference. HPV's Awareness Day is next week, as Lenine pointed out to me earlier. And he took the time to meet me in Cape Town at CTICC, and we had lunch. And he said to me, these biomarkers that you're describing, have you ever thought of translating them? So I said to him, well, we publish, and then we hope somebody else takes that information and does something with it. And he sort of explained to me Horizon 2020 and how they've got industry, research, and then sort of the public health aspect, and how these teams working together can actually make a real difference. And about a year later, the SAMRC published the Strategic Health Innovation Platform grant, and I thought it was really interesting to take the biomarkers we've described and explore how we could translate these into a tool. Because he pointed out actually sometimes, industry's not watching, or all of these discoveries that we're working so hard hoping somebody takes forward don't make it. And we were fortunate to have the funding granted from the MRC, and that was the beginning of this Genital Inflammation Test, or GIFT, for HIV prevention, which Lindy and I coined, which we thought was the beautiful acronym. And we've gone with it. And the way this was pitched to the MRC and the grant, and how we talk about how the genital tract inflammation test sits in the pipeline, it's a triage test. So it's a screening tool to allow women or healthcare providers to decide from a big pool of women coming into a family planning clinic, hypothetically, who gets a diagnostic for chlamydia or gonorrhea, who needs one, and sort of in that way link them up to the near point of care, Gene Experts, and other platforms that exist. STI tests are very expensive, and governments like South Africa can't afford to offer routine screening for an STI. So who decides who gets access or who doesn't? And currently nobody gets access unless you've got like symptoms that a clinician would see, and then you don't get the test. You just get presumptively treated with a cocktail of antibiotics that cover the likely suspects. So since, presenting the findings in 2015 about HIV risk factors, we did a lot of work in the background through other cohorts looking at if sexually transmitted infections and bacterial vaginosis are the strongest predictors of inflammation, what biomarkers perform best, and of the ones through modeling and quite sophisticated bioinformatic approaches, IL-1 alpha, IL-1 beta, and RP10 together, the combination of those three cytokines, correctly classified 80% of women with inflammation associated with an STI and BV. And the discovery work was done in Caprisa, and this is looking at how signs and symptoms work, which you can see is like tossing a coin. Sometimes you're right, sometimes you're wrong. And subsequently from Caprisa, we've enrolled into the Women's Initiative in Sexual Health study, and then a collaboration we had with FHI 360 FemPrep, and the biomarkers work well over all of those conditions. And the different colors we've shown here represent different kinds of samples. So it doesn't matter what kind of samples you collect from women, and essentially it doesn't. So this is the pipeline that we've been through, the path, what I've done with the last 10 years of my life, and what Lindy's done with the last 10 years of her life, in between having 2 children, etc., etc. Lindy, not me. But so biomarker discovery, 2014 was our path. We partnered initially with Lateral Flow Labs at Capricorn Park. There are device developments. They were initially associated with Alere and then kind of went private. And through SAMRC investment, we did, and partnering with Health Economics at UCT, we did an affordability study which has been published. We've got a cost effectiveness study completed, and these are all tools that we have to put in place when we negotiate with key stakeholders who are going to buy the test eventually, and convince government to introduce this as a new approach for reproductive health. The University of Cape Town, through their Research Contracts and Innovation Office, have been involved since early days, assisting with paying for the patent, preparing all the legal work that goes into that. That process of becoming versed in what a patent is and how you apply for patents and what it means and who pays for it and how much it costs and where what it takes to assign novelty, what you have to prove when you apply for a patent, and then who goes on the patent and who are enablers, and all of that stuff is really important. Well, important, but it's actually quite interesting as well. As if you're an academic and you like learning, those are really interesting pieces of information. And then we got funding from the Technology Innovation Agency early on to develop our own monoclonals, because if you're developing a lateral flow test, and this is an example of the first prototype from Lateral Flow Labs, it's literally a nitrocellulose membrane on which antibodies have been strapped. It's very similar to an ELISA, but more similar, I would say, to Western blot in some ways, where you've got your capture antibody and then you've got your detection antibody, and the detection antibody has got a colloidal gold tag, and what you see as the red line is this colloidal gold band on it. And it's really quite low-tech under the hood, and that cartridge drives 80% of the cost, and it's a disposable plastic. So if anyone's in the business of making, I don't know, more eco-friendly devices, there's a market. And in 2020, we had the first batch, but we weren't confident enough for this first batch of devices in terms of their performance to move forward. And we took stock. COVID happened, and we wrote up an enormous grant from the European Union, EDCTP, to fund the next phase, which allowed us to pivot to a new manufacturer who could kind of take it through. But I think the key thing is, unlike a pregnancy test or I don't know, any other rapid we're familiar with, a COVID test, the amount of antigen, the concentration of cytokines this test has to develop is in the picogram levels. Most pregnancy tests and COVID tests, antigen tests, are sitting in the nanogram. So the quality of antibodies you need to immobilize onto your membrane have to be really beautiful, very sensitive antibodies to pick up very low concentration analytes, which is something we didn't factor in when we were going into it 10 years ago. And it has been a challenge to kind of push the performance of quite a simple platform, a nitrocellulose membrane rapid, for something as unstable and at such a low concentration as a cytokine. I'm preempting sort of some spoilers later. So we've been working with Medical Diagnostic, which is Ashley Ace and Linda Munger, just down the road in Brackenfell, quite close to here actually. And this was a significant investment from the EDCTP for quite a complex consortium. So we reached out to them. They're a private company. They're a commercial enterprise. And people from our lab, our students and postdocs, to go to Meditech to work on the device in their facilities. A lot of just know-how and goodwill, and that's public-private partnership, academic industry partnership. So if you find the right people, I think we've taught them some stuff too. But I just wanted to give Lyndon in particular has been our go-to person on this, and Daryl Ace. So Daryl Ace is Ashley's brother. The whole family works there, and that's another strategic. If you want to start a good company, get family involved. They'll look out for you.
Medical Diagnostic was established in 2010 as a developer and manufacturer of lateral flow rapid diagnostic test kits. We manufacture high-quality rapid diagnostic test kits using our trade secret methodology for increased sensitivity and early detection. Our products are robust and are optimized to withstand extreme storage conditions for up to 24 months. Lateral flow tests are manufactured under ISO 13485 accreditation and includes tests for alcohol consumption, drugs of abuse, HIV, malaria, pregnancy, and fertility and ovulation. We also offer contract manufacturing and development services for new innovative lateral flow components and test kits. Our team of experienced R&D scientists work alongside customers through each stage of development. We provide regular updates, advice, and joint troubleshooting strategies throughout the development process. The intention is to provide services in molecular genetics, development, validation, and manufacturing of real-time PCR-based probe melting assays and point-of-care molecular tests for mutation detection and pathogen testing. Our lab is equipped with a real-time PCR cycler with 5 fluid.
And it's been a pleasure, if Lyndon's listening at all, it's been a pleasure working with them. So the next part of our learning journey was actually kind of becoming more interested in the details of regulation and what it would take to get it through SAHPRA and get it approved here in South Africa for use, but also in Europe you have to get a CE mark. So we've seen CE on a lot of the imports, and most of the stuff we use in South Africa isn't locally made. In fact, Medical Diagnostic COVID test was like one of the first locally produced tests that were SAHPRA approved. And if you're going through what's in a test, there's a lot of legislation from the WHO, a lot of ISO guidelines you have to read through about what is a kit. Lenine will be very interested in this. If you're going to SAPRA or you're going to register a device, depending on what kind of level of effort they put into, or what kind of stringency they put in the evaluation, you've got to look at what components are in your test. So we have a flocked swab, which we purchase from another supplier. The flocked swab comes in contact with the vaginal epithelia. Therefore, that's quite an invasive procedure. Even though it's not going into the mucosa, it could cause mucosal damage. So it's a Class A invasive device, even though it's not our device. Even though our device is this little plastic thing at the end, which is a non-invasive device. And then the other thing SAPRA take into account is if our test gets it wrong, what are the implications to the patient? In the case using HIV as an example, if an HIV test gets it wrong, the implications ethically and medically and legally for the patient are enormous. So the kind of stringency for an HIV test is very high. If you're going to be treating a patient with an antibiotic, you want to know that the results of your test are accurate, reliable, etc. So we've been doing a lot of this, homework, reading around, and this isn't my everyday expertise. I've had to stretch myself, and our teams had to stretch ourselves a little bit in kind of reading through and doing due diligence on all of these things. And then this is a little bit of a spoiler because I don't have actual results to show you from the field study we've just finished, but this is the RP10 device that we're very proud of because this is quite a tricky cytokine. It's quite a powerful cytokine. It's been linked with HIV risk as the strongest biomarker of HIV risk. STIs aside, if you're looking at something that shouldn't be elevated in the vagina of a woman, it's RP10. And this is one of the Meditech devices. And the control line just shows you that the test is working and that you can trust the results of the rest of the test. And then this is the band for RP10. So you remember there's a capture antibody on the bottom and the detection antibody on the top with the colloidal gold stain. And this is the dilution series in picograms per mil. So you note that at lower, so this is picking up to 250. There's a faint little band at 125, but this result shows us that potentially the test is semi-quantitative and that the intensity of the band varies by how much cytokine is there. And it also shows that it's getting down to about 250 picograms reliably. And if we use an automated reader, which is this is an image from the automated reader we used, we can start seeing bands at about 125 picograms per mil. And then just in terms of the competitor analysis, currently GIFT is sitting at about 70 to 80% accuracy, but at just less than 100 Rand in cost, including the antibodies. And this is a lot cheaper, a lot more expensive than syndromic management, but a lot more accurate. And then at the other spectrum, we get the more expensive tests, which exist in a lot of the NHLS labs, a lot of the private pathology labs, and near point of care, which is Gene Expert, which is more expensive and more accurate. And just to remind you that the genital inflammation test is intended as a triage test to indicate who gets access to these more expensive diagnostics. And this is the funding application we were successful in, and it's just coming to an end soon. It was an enormous collaboration between 9 institutions spanning South Africa, Madagascar, Zimbabwe, Australia, the Netherlands, Japan. Who else do we have in the mix there? it was a really interesting and powerful enterprise, and with all EDCTP grants, they come in work packages. So the University of Cape Town was a primary recipient of the award and did all the subcontracting. Lindy Masson immigrated not so recently to the Burnett Institute in Australia, in Melbourne. So she led the device manufacture, which was done locally in South Africa with medical diagnostic, and her teams of postdocs and PhDs are still studying at the University of Cape Town. Institute Pasteur took the lead on the clinical study, and that was Tanya Crucitti, with 3 clinical trial sites in Africa. We had a really impressive work package on how to integrate the device into practice. So it was kind of like visionary by Susanna Francis, who's now at IRV, who was at that stage at the London School of Hygiene and Tropical Medicine, who led that part of the work. But that was like speaking to women and nurses about their experiences with the device, like user experience, discrete choice experiments, health economics, machine learning for the algorithm, so how this device will eventually fit into an algorithm. And another activity was a Delphi questionnaire, so like engaging with stakeholders and building consensus about how you, so these are all like new tools that we wouldn't have known about if we didn't have these collaborations with colleagues. And then the University of Cape Town Research Contracts and Innovation has been leading the pre-commercialization piece. It's like how we take all this information and we kind of put it into the next steps, and we get ready for registration of the device and going into that pre-commercial space to see, you know, how stakeholders engage with it. This is a summary of the full process we've been on. It's a lot of detail to unpack. It is on our website, but essentially we started in work package 2 with making the device with medical diagnostic, screening close to 1,000 different antibody combinations, like capture. So not all antibodies play nicely together. They've got to recognize distinct parts of the antigen you're trying to, you know, so you've got to like almost do a cross board of every antibody combination for all 3 biomarkers. Once the devices were manufactured under ISO conditions, they went to the clinical trial sites. Stability testing of the devices continued during that time, and improvements. And then this trial ended December 23, and in parallel, all of the how we're going to integrate the device activities took place. And then we've been drafting a pre-commercialization plan and moving forward with the protocol with SAPRA for testing the final device in its final iteration. So I hate showing very busy pictures like this, but my apologies. This is just the high-level view of the activities that we completed. This is key milestones. So we finished the first device. So we got the funding in July 2021. A year later, we had the devices finalized, and that was predominantly Meditech and the University of Cape Town, with Lindy Masson at Burnett and David Anderson, who's her mentor at Burnett. And then we completed the clinical studies. They started enrolling in July as soon as the devices were ready, and we enrolled a total of 675 women across the 3 sites. And this was done led by the Madagascar team, and enrollment was closed in December 23. Data cleaning took quite a while. It's quite a complicated study with a lot of endpoints. So the database was complete and locked in May, and then we did an enormous amount of ELISA work. Michaela Lurie, if you're listening, shout out to about 4 months in the lab with Ngamso Kawa, who did all of the cytokine work, and we're busy looking at the microbiome and other things. Deneen was going, okay, there, I can see the time at the top. And yeah, so the microbiome stuff's still ongoing. and we are going to be presenting the final results in July. And the most important thing is we had an amazing end of study workshop in Madagascar in Antananarivo, and the focus was on specific use cases for this device, which is now going to be registered as an inflammation test. There was a bit of unsureness with this user experience of people's understanding of what an inflammation test is versus what an STI test is, and a lot of confusion about GIFT does not detect the presence of a specific STI, but it predicts the underlying pathology associated with it at that STI. Some shout outs for things we're proud of. GIFT was I participated in a Leaders in Innovation Fellowship, which is run by the Royal Academy of Engineering, and it's a partnership with the Technology Innovation Agency, and I was part of the LIFT cohort 7, so it's the 7th year it was running. It's a brilliant program for taking like people that are entrepreneurially minded and getting them like improve your website, have an elevator pitch, you know, all of the nuts and bolts if you're going to go into industry and sell this thing that you're making, what you need to have in place and all the regulations associated with that. Because we were finalists and I think we came second overall, I got to participate in a podcast, which was an amazing opportunity and a little bit out of my comfort zone. And we've tooted our own trumpets in the conversation, telling about, you know, the project and how it's going. And then where we are currently, we finished all of the activities in the top here. We are finalizing the device with Meditech, and we are preparing for the SAPRA trial. We are going to be doing it with a DTHF, Desmond Tutu HIV Foundation, with Catherine Gill as the PI for SAPRA, with strong support from Linda Gale Becker. And this is the reason I wanted Lenine to stop me early, was that I kind of talked about my journey, but you know, I'm also part of this Calesta Schumer scientific leadership initiative, which has been really powerful. And this is my call to action for everyone sitting in the room who's younger than 40. In the US and the EU, about 50% of PhDs graduated in the US and 20% in Europe go on to industry, biotech industry, for their employment. There's no data for South Africa as of yesterday. I looked very hard. I know a lot of PhD scientists, especially before they graduate, are concerned about their career opportunities in South Africa. They've spent all of this energy and effort. They've got this amazing brain capacity for science. There's only academia in South Africa. There's a really, really sparse biotech industry. If I could do it in my mid-40s, you guys are like going to be flying. And it's a really like important part of you. You've got all the skills and the tools, and I don't think we recognize that. We're not trained that way. We train quite academically. We import 80% of our pharmaceuticals, which means we are very vulnerable to supply chain demands, which COVID taught us a real lesson in. Most biotech innovations occur in the global north, and then we import them, and they focus on diseases that are very prevalent there using data from the global north. Biotechnology, more commitment to biotechnology can drive industrialization and create high value jobs in research. So each of you, if you kind of set up biotech or get biotech skilled, you can employ scientists and create a source of, to keep people in South Africa, because South Africa produces above its weight in PhDs. We really do well in producing PhDs, but a reality is that a lot of the PhDs don't see a future for themselves in South Africa, and they'll head elsewhere where there are opportunities. And a thriving biotech sector attracts foreign direct investment, venture capital, public-private partnerships. We have world-class universities and you sitting in this amazing facility, but we have limited commercialization of our research here. So we could create innovation hubs, and I think there are, Cape Town's quite good with that. Yeah, most talented scientists leave, and having this thriving alternative work opportunity in South Africa would retain talent. And we would also encourage people that are working outside the country, because it's really important for people to go after their PhDs to get postdoc experience and bring it home, but that they've got something to come home to. And with that, I'm going to, those are my pearls of wisdom. It's never too late. And I just wanted to thank a really large team from many different countries and places in Africa for what I presented today. So thank you very much.
Don't go far. That was so exciting. One of the reasons we had to have Jo-Ann here today was to describe this this journey that you've been through. You started off during your talk saying the mindset was that your research is just something that you do and you put in a paper and you move on. Someone else can do something with that, translate it. We need to change that. And I think some of you have seen in our recent launch, the African Stars Fellowship, where we do have a program, thank you very much, I'll shout out, that focuses on nurturing this entrepreneurial skill set within scientists, so that your research is not only focused, stuck in the lab. It is something that can be translatable, skills that you can build to eventually, as Jo-Ann says, start your own company, employ other people. MedTech, diagnostic, Ashley Ace and Lyndon Munger, if you're on the call, they were I met them. They were with me in undergrad. So this is real life experiences here, right? I mean, if Jo-Ann can do it, if they can do it, we can do it as well, right? It's just a mindset change of your research just belongs in the lab. No, we are here in the business of helping people. Sorry, that was just me. The floor is open for questions and comments online and within the room. We do have a roving mic, so if anybody would like to ask a question, please do just raise your hand or pop a question online in the Q&A section. I think we have a question at the back. Oh, I thought you did. Okay, can I kick off the questions, please? I'm very excited about this. Excuse me, I'm taking host prerogative here. So this mindset change I mentioned now, when you gave a whole very detailed description of the project from the beginning all the way to product. What would you say would be the key messages for, let's say, a master's student or honors student now to be preparing themselves for to eventually get to a position where they can sell or market an innovative project that they've designed? What sort of skill sets can we be developing now for that future happenstance?
So just using the Leaders in Innovation Fellowship experience, I think key shifts in thinking, so around like the impact of your research, what it could translate into, and they're tools and mechanisms in how we think about stuff. So a PhD student should be encouraged to have like a impact reflection, which they do in their PhDs, but also like how this could be translated. What are like the next steps? And I think from our side, we had biomarkers, and then the next step was the technology platform that we would put this on, and some of those considerations. There's enormous value in speaking to the right people, which we do naturally as scientists. We consult with people, and people are generally quite generous with their advice. So get recommendations from who you should speak to as you start the journey. But it's not a different world, is the message. And there are a lot of online resources as well in preparing for innovation and entrepreneurship that you could easily self-learn. But it's a shift in mindset in like speaking a language that's not academic science, but more targeted at investors and the innovation pitch, and what information they would need in the innovation pitch is really key. So basically the whole year of Leaders in Innovation we spent on the innovation, like the 1 minute pitch. And that 1 minute pitch is so powerful for a scientist, because if you're at a conference, to talk about what you do in 1 minute to get what you want out of that transaction with this person, even if it's a talking transaction, is really powerful. So yeah.
Thanks. So, oh, hi. Oh, okay. So thanks very much. I really enjoyed that. So you've made it look very easy, though. So my question is, what was the most difficult part of this process, in your opinion?
So I made it sound easy because I'm sitting at the sort of the more management. So I can talk about what was challenging and sort of keeping the collaborations going, and what potential roadblocks were. But in terms of executing it at the ground, I think in every work package, actually making a device, being able to detect an antigen in the picograms has really pushed the envelope on, and we couldn't get it right with our first manufacturing partner. We then had a second manufacturing partner to get there. So the technology in that was like a real challenge, and it was achieved, and at great reward, because we have a first working prototype, and getting others to buy into the thinking, because it's shifting the narrative for clinical practice on an inflammation test for a condition most people don't know they have. And then if they get the information, what do you do about it? So some of the thinking around that, the more epidemiological and human-centered pieces around that were quite challenging. And I don't think we've got the answer to that yet, because it's crafting in the message, like what the information the test gives you is telling you, and what you can do about it, like what clinical action it will take from a clinician. So I think engaging with clinicians and key stakeholders like early on, because most of us feel we'll only be able to have the confidence to present something to people later on in the journey, and actually just having that early insight and speak to people early on in your journey before you have a complete product. So you don't, and another example is, don't go to the Department of Health with a device that you've made because you think they need it, but go to them early and say, well, like, what kind of device would make a difference, or what can we be doing? So it's like shifting when you speak to people, which I think is like counter how we trained as scientists in a way, because there's like, you only put a paper out there when it's published and it's all the kinks are sort of ironed out. So it's a little bit of like trusting people and speaking to the right people early on, and having different conversations with them. Don't go to your end user and say, this is what I've made for you, but go to them and say, like, early on in the process, say, we're thinking of doing this thing. What do you think? How can we make it adapted? So
we have time, but squeezing in this one more question. There's a question online asking, for anyone seeking to translate research to a product, would you recommend seeking startup funding from traditional funders, go directly to industry partners, or perhaps a combination? Where do we get our money from?
So that's a good question, and it depends on the innovation, on who you develop partnerships with. I would say all of the above. I don't think there's like you need to find the right partner and you need to convince them that this is an investment worth making. There are these boot camps for training entrepreneurs to speak to investors. And they kind of do help training. I've never actually stood in front of investors and pitched this to investors. We've always done the grant funding, and if I'm probably not the person who's going to stick with this because I'm like getting a bit long in the tooth. But if this goes into manufacture and commercialization, what those conversations are, I'm told that something like GIFT, which is everything we do is very pro-poor, low resource setting. Governments are going to be our end user. We're not looking to make $1 million out of this. And that is counter what investors want to hear. So sometimes, so ours is a social innovation. There's even these buckets of what kind of innovation it is. It's a social innovation which will have social impact, and therefore an angel investor, which is kind of a philanthropist who thinks it's a really good idea and can have the impact you want, would be your go-to. I hope I haven't shot us in the foot there if anyone from the UCT team's speaking, but I'm quite open about that. So it depends on what the intention is and who you go to. And then you also have to align with investors that have the same vision as you, which I think is the key thing.
Thank you so much, Jo-Ann. Thank you for your time. Thank you for the pearls of wisdom over here. She deserves another round of applause. Thank you. We've heard how important communication is, forming good networks, trusting the people that you're working with, being able to find funding partners as well, great skill. And I hope that we've brought into the importance of this mindset shift, mindset shift from your research just belongs here. It doesn't. We can grow, we can work together to get what we have in our minds and on our benchtop outside and helping more people. Okay. Thank you very much for joining us today. I need to just remind people for CPD points in the room, please do sign our register outside. In the next couple of minutes, we'll have a networking section outside over food and something to drink. And we look forward to seeing you at our next CERI seminar series in March. Take care, everybody.